So let's practice another one that is ambiguous. So we're going to have a big A, little a, big B and little b, big C and little c. And we are told that little a is 7, and we are told that little c is 5, and that big C is 30 degrees. So again, this is ambiguous because I'm missing 2 angle measures. There's no way I can immediately figure out what the angle measures are. So I'm going to reassign my variables simply for the ease of applying this mess right here. So my completed ratio will be my A's. So big A is 30 degrees and little a is 5. And then little b is going to be 7. So check first, is A, little a is bigger than B? Is little a bigger than B? No, it's not. Okay, so we do not have one triangle. Okay, at this point, I need to find out what H is to determine what's going on. So my H is going to be B times the sine of A. So I have 7 times the sine of 30, which is going to give me 3.5. If you'll remember, the sine of 30 is 1/2. So 7 times the sine of 30 is 3.5. Okay. So now go in order. I just found this. So is this smaller than this, which is smaller than this? Yes. So H is smaller than A, which is smaller than B. So I've confirmed that I've got 2 triangles going, because H is smaller than A, which is smaller than B. So I do not need to have my reassigned variables. I need to go back to my original variables. So this time, I'm going to leave a little bit more space in between. So I've got big A, little a is 7. I've got big B and little b, and big C is 30 degrees, and little c is 5. So I'm going to find this blue stuff first. So use your completed ratio. So the sine of 30 degrees over 5 is going to equal the sine of big A, over 7. The sine of big A over 7. So cross multiply. I get 7 times the sine of 30 equals 5 times the sine of A. Divide both sides by 5. And then take the arc sine of both sides. So the arc sine of 7 times the sine of 30 divided by 5 is going to be 44.43. 44.43. So I know that that is what A is. So 44.43 degrees. Now immediately subtract that from 180 and you've got your other possibility. So minus 180 is going to be 135.57. So positive 135.57. So now I've got the scenario for both of my triangles going. So let's finish up with the blue one. I can figure out what big B is because I've got 2 out of 3 angles. So 180 minus 44.43 minus 30. Ooh, that's a lot of stuff. All right. Somehow I managed to hit that twice. All right, so 180 minus 44.43 minus 30 is 105.57. So big B is 105.57. Now use your original unrounded ratio. So the sine of 30 over 5 will be the sine of 105.57 over little b. Cross multiply. So b times the sine of 30 will equal 5 times the sine of 105.57. And then divide both sides by the sine of 30. So any number divided by itself. So I have 5 times the sine of 105.57 is, divided by the sine of 30, is 9.63. So I find out that this side length is 9.63. So I've got a completed triangle. Now let's go finish this one. So I know that if I subtract those two angles from 180, I will get 135.57, the remaining angle, which is going to be 1443. So this is 14.43 degrees. And now start with your initial ratio. So the sine of 30 degrees over 5 will equal the sine of 1443 degrees over little b. Cross multiply. So little b times the sine of 30 is 5 times the sine of 14.43. And then divide both sides by the sine of 30. So I've got 5 times the sine of 14.43 divided by the sine of 30 is going to give me 2.49. So this side length is 2.49. So those are your ambiguous cases. And so now, oh no, let's go in and do some practice application problems. So I'll do about half of these, which means we're going to go into another video. But we can do this. So I have a figure. So let's zoom in on it. Okay. So I've got this figure, and it represents a ski lift. So I'm going to rewrite what we have. Okay. So I have, come this way. I have the sine. What? I don't have a sine. I have a ski lift. All right. I have this right here. I know that this is B. I know that this is A. And I know that this is C. And I'm told that the length between them, I'm supposed to consult a figure to find the length of the span of a proposed ski lift from A to B. So I am finding, where's my highlighter? The length of the proposed ski lift from A to B. Okay, a surveyor measures the angle of DAB. So this is D over here. So DAB is going to be 25 degrees. So that's 25. Okay, die. I'm sorry. Whatever. Anyway, that was violent. And then, hang on, I've lost control. A surveyor measures that DAB to be 25 degrees, then walks off a distance of L being 1,000 feet. So this is 1,000 feet. And measures ACB to be 15 degrees. And I want to know what's the distance from A to B. Okay, so basically I'm trying to find out, first of all, remember that this right here is supplementary. So 180 minus 25 is going to give you 155. So I know that this angle measure is 155, which means I can find the third angle measure. I can find this one. So 155 plus 15 is going to be 170. So this is 10. And now if you ignore this part, you'll notice that you have a completed ratio. So I want to know what this is so that its corresponding angle is going to be 15. So to finish this out, I know that the sine of 10 over 1,000 will be the sine of 15 over that length that I need, that length of AB, which I'm just going to call A. Okay, so cross multiply, I get A times the sine of 10 is 1,000 times the sine of 15. And divide both sides by the sine of 10. And so 1,000, oops, that is too many zeros, times the sine of 15 divided by the sine of 10 is going to give us 1490.48. So the length of the ski lift is 1490, what? 48 feet, or whatever it is we're dealing with. Feet. Okay, so that was enough, an application. So let's do another one. We'll do a representative sample. We'll do a representative sample. All right, so we have an airplane. Fly. What is the deal? Sorry, another gnat flew by. What the heck? Sorry. All right, we have... I'm going to get it. I don't know where they're coming from. All right, so this is my airplane. This is X, and this is Y. This makes a right angle. And so I'm going to fill this thing in. So what I have then is... waiting for that gnat to fly by. All right. So I have this triangle. And here's my little airplane. Look at my drawing skills. All right. So I'm told an aircraft at Z, right there, is going to be spotted by 2 observers at X and at Y. So this is Z up here, who are 1,450 feet apart. So this length at total is 1,450. Okay, as the airplane passes over the line joining them, each observer takes a sighting of the angle of elevation to the plane, as indicated in the figure. If A is 35, so this is 35, and if B is 35, okay, then how tall in the sky is our airplane? So I know 2 sides. I can find this remaining angle. Okay, so 35 and 35 is 70. 180 minus 70 is 110. Okay, and I can use thank you. I can use the fact that this is now an isosceles triangle. Okay, so if this is isosceles, that means that this thing was bisected. So if I'm trying to find this height right here, I can chop this thing in half. Okay, because this is a right angle right here. So half of 1,450 is going to be 725 here and 725 here, which means this is 55 and this is 55. So if I just want to know the height, I've got 2 isosceles triangles. I don't care which one you grab. I'm sorry, they're not isosceles. I've got an isosceles triangle. I don't care which one you grab, because either one, I'm going to find this. So I have a completed ratio of 110, which is split in half, to 55. So I have the sine of 55 over his corresponding side of 725 will equal the sine of 35 over my height of my airplane. So I'm going to cross multiply. So the height times the sine of 55 is 725 times the sine of 35. So cross multiply. Divide both sides by the sine of 55. And we will find out 725 times the sine of 35 divided by the sine of 55 gives me 507.65. So the height of my airplane is 507.65 feet, which is not high. Okay. All right, so we'll do one with bearings in it. And then we will set you free to finish the rest of this. So this is going to go a couple minutes over. But Adam must fly home to City A from a business meeting in City B. So we're going to have A, and then he's going to fly home to City B. Okay. One flight option connects directly from City A to B, which is a distance of about 457.2 miles. So 457.2 miles. A second option flies first to City C and then connects to A. So here's City C floating around. Okay, and then connects to A. The bearing from B to C is north 28 degrees east, which means I labeled this wrong. This is going to be B, and this is going to be A. Okay, so I've got B. I'm at north, so if I'm sitting here, the bearing from B to what? The bearing from B to C is going to be north, 28.9 degrees east. 28.9 degrees east. So if you look at this as B is being your origin, then what I have is I started at B and I swung out 28.9 degrees to the east. So this right here is 28.9 degrees. Okay. The bearing from B to A, so here's B again, being at the origin. From B to A is north 59.7 degrees east. So north 59.7 degrees east. So from B to A means I swung out from B all the way over to here. So this whole thing right here is 59.7. So this is 59.7 degrees. Okay, so I want to know a couple things. The bearing from A to B is south 59.7 west. So south 59.7. So here's what we're looking at. If A becomes my origin, then what I did was I was at south and I swung over 59.7. So I know that this angle is also 59.7 degrees. Okay, so that's how we're going to read our bearings. Well, now we got to figure out what's going on here. So I want to know, what do I want to know? How many more frequent flyer miles will Adam receive if he takes the connecting flight rather than the direct flight? So I know that this direct flight is going to be just 457.2 miles. So I need to find out how far it is from here to here, and then from here to here. Okay, so I got to find out some angles first. So looking at this, I can draw, oh, look at that. There's already a line. Okay, I can draw a line this way. So I know if this portion is 28.9, okay, I know that this entire portion right here will be the complement of that. Okay, so I'm going to look at this portion right here. Okay, so that portion is going to be what? I've got 90, that's a 0, 90 minus 28.9 gives me 61.1. So this is all 61.1 degrees. Okay, well, I know from here to here is 59.7. So I need to know what the overlap is. Okay, how much is it from here to here? And then I can figure out just the part in my triangle. Okay, so if I want to know, I know that from this axis to here is 59.7, which means this part is the complement. So 90 minus 59.7 is going to give me 30.3. So I know that this part is 30.3 degrees. Okay, so let's kind of shade this in a little bit. This is 30.3, and I know that this is 28.9, okay, which means now I know what the center of that triangle is, not the center, but I know what that angle of the triangle is. So we're just going to draw the triangle this way. So I also know that this is 457.2, okay, so what else do I know? I know that if I subtract these two shaded parts from 90, so 90 minus 28.9 minus 30.3 gives me 30.8. So this angle measure right here is 30.8. That's what I know so far. So now I've got to figure out, using this angle over here, I need to try and figure out what my remaining angles are. Okay, I was freaking out. I forgot to read part of the problem. All right, so what we have also is that I have a bearing that I missed. The bearing from A to C is north 78.7 west. So from A to C, so that means I'm starting at A, so that's the origin. from A to C is north, and then I swing out 78.7 west. So this part is 78.7, which now means I have another angle. Okay, so I was like, there's no way for me to do this problem yet. All right, so I know that this one plus the missing part must be 180. Okay, so I'm going to do 180 minus 78.7 minus 59.7, and that gives that little part in the middle that I was missing, 41.6. So this is 41.6 degrees, which means this is 41.6 degrees, and now I can find my other angle, which means I'll have a completed ratio, and I can dive in and go from there. So this triangle, which is this one up here, okay, I'm finding this angle right here, which corresponds with that. So I'm going to do 180 minus 30.8 minus 41.6 gives me 107.6. Okay, and so I've got a completed ratio. So the sine of 107.6 over 457.2, I'm going to go for the smaller angle, equals the sine of 30.8 over, we're going to say B. So cross multiply, I get B times the sine of 107.6 equals 457.2. You cannot see what I'm doing. 457.2 times the sine of 30.8, and then divide both sides by the sine of 107.6. So when I do that, 457.2 times the sine of 30.8 divided by the sine of 107.6 gives me 245.60. So this is 245.60. Now go back up to your original angle measure, or your original ratio, and we're going to find this way. So I now have the sine, different color, of 107.6 over 457.2 will equal the sine of 41.6 over that other side. So I have C times the sine of 107.6 is 457.2 times the sine of 41.6, and now I'm going to divide both sides by the sine of 107.6. So that gives me 457.2 times the sine of 41.6 is divided by the sine of 107.6 is 318.45. So this is 318.45. So the question is, how many more frequent flyer miles is he going to get? So if he goes from here to here to here, so from A to C to B, how many more miles will he get? So 318.45 plus 245.60 gives me a total of 564.05. Whereas my original flight would have been 457.2. So subtract that. And I find out I'm going to get 106.85 frequent flyer miles, which I bet rounds up to 107. So you should be well equipped to finish section 9.2.